Earthlings, welcome back to my channel, the Only Lauren channel. I'm Lauren, your hostess and professor and all of the above. Today we're going to be talking about the 6 branches of physics, the 6 main branches of physics for your requisition or your acknowledgement and everything. And I'm just gonna explain a little bit to you guys what it's about, and let's just get into it. And make sure you watch this video to the end and support my Patreon so I can keep making videos like this and stuff. So this is a requested video by you guys, so I want to make sure that you take notes. It's always imperative that you take notes because there are things that are gonna show up again for you, and I hope you're studying the maths. So first I want to talk about what is physics, and actually I'm gonna say some things that are not particularly obvious about physics from the jump. Initially, people think that it's hard. For sure, it's not so much as hard so much as it's time consuming. There's quite a bit of things to get done. So that's the difference between what's happening in physics, what you think it's happening, or what is actually happening. So what is physics? Well, physics is the study of the knowledge of nature, or the nature of knowledge, or the knowledge of nature. Yeah, we study matter, its motion, and its behavior through space and time, and those usually consist of energy and force. And it's pretty much the fundamental building blocks of everything around us. Like, for me, it's the end all be all of all sciences. It's the apex. You gotta put your Rockefeller sign in the air. That's how awesome it is. So we talked about the definition of physics, but we didn't really talk about the etymologies. We kind of specialize in here on this channel. One of the root of the words physics is from the Pi root behu, which means to be, to grow, and exist. I like to think of physics as the description of poetry of the universe. That's one verse, universe. You're gonna want to write that down, take notes, because that's gonna come up again. That's like my big one. Bigger than the other big one? Yeah, that's bigger than the big one. So you really don't need any other sciences. I mean, well, the other two, sciences that are chemistry and biology. And another thing about the physics is that we do when we study physics is we write out long mathematical proofs and to show the prediction of the behavior, which consists of like long ass problems. And honestly, it's for nothing more to be able to say that you can do those long problems and that you can do it. Honestly, it's not necessary. It's just there's a word for it. It's not poppycock. It's maybe a bunch of poppycock. One of the most common ways we show those proofs is using calculus, and one of the favorite ways to use that calculus is proof by contradiction. And I feel like I could do another whole video about proofs, because there's not just proof by contradiction, there's also proof by induction and direct proofs, which is my favorite. I think they call it constructivism or intuitionism. The answer's right there. But you want to prove by saying something, prove something is true by saying it's not true. Proof by contradiction. Who can know? You guys will see me doing proofs, which is usually just like the maths or whatever. And I know sometimes like I'll like say the wrong thing. I'm not the answer is right, but I'm saying like the wrong verbiage for that particular equation or problem that I'm working out. So if you see that, just realize that the answer is right, the results are right. I just didn't say the correct term for that one. Okay, I want you to know that Lauren is right. One of the things we have in physics is we have something for errors called the Heisenberg uncertainty principle, which is basically something we factor in. It's like a plus or minus by 2, and this may be off a little bit, but it's going to be mostly the correct prediction. And the formula for that is sigma sub x times sigma sub p is greater than or equal to h bar over 2. I'm saying quite a bit because I'm not sure. I can't remember if this is sigma or not. So you have to, this is what I mean by the verbiage. But you basically gather the principle of what I'm trying to say. And I hope you know some algebra because that would be very helpful. I'm mostly using algebra. So we talk about some of the branches that most people know of. There's theoretical and experimental physics, and it's also split into Newtonian physics and modern physics. So those are the two separate ones from each other. Modern physics is the new physics that Newtonian physics couldn't explain. So now we're gonna get into the 6 cores of physics because I feel like you should know what I know. So the first one is going to be mechanics. It's our fundamentals, our basics. We talk about length and mass. Over time, almost everything is going to be over time dependent. That's just what it is. We're talking about motions in 1 dimension, 2 dimension, vectors, coordinate systems, laws of motion, circular motion, energy of a system such as work done by a force, conservation of energy, linear momentum and collisions, angular momentum, static equilibrium and elasticity, gravitation, well, universal gravitation, and fluid mechanics. I feel like if you can master mechanics, then everything should be like a walk in the park for you. I feel like you should be able to make it through. Number 2, oscillations and mechanical waves. I do this one a lot. So oscillatory motion, like the classical pendulum, one that everyone knows about. Wave motion, like propagation of disturbance, which I talked about in my evil video. Sound waves, y'all know about that. And superposition and standing waves, like in resonance. So like if like resonance is like, you know, when you hear Ariana Grande sing, like I think she has like some of the best resonance I've ever heard on a singer. Honestly, I've only like hear resonance with her voice. I don't think she's meaning to do it on purpose. I think she's going for vibrato and it comes out resonance. So when she's like, just keep, can I do it? Breathing bit. It's not like, it's like the okay, I can do it. Yeah. Okay, you don't want none of that. Thermo kind of happens to be one of my favorites, probably because it's not so time dependent. Actually, very little time dependence, if any. I mean, I know I said all things over time. Technically it's in time, but your problems that you work on in thermo won't be time dependent. So some of the things we talk about in thermo are temperature, the first law of thermodynamics, which basically says energy of the internal system is set and it just moves on from one form to another, which technically contradicts the Big Bang Theory, but we're not going to talk about that right now. The kinetic theory of gases, heat engines, and entropy. And the second law of thermodynamics, which basically says that you can never reverse what has already been happened, what has already came to be, which is weird, but it kind of goes without saying, but at least you can, you know, measure it. For electricity and magnetism can be a little lackluster, and you know, unless maybe you're studying like planets and stars, it's kind of like, it's not as great to like learn about. There's electric field, Gauss law, electric potential, capacitance, dielectric, current and resistance, direct current circuits, magnetic field, the sources of the magnetic field, Faraday's law, inductance, alternating current, and electromagnetic waves. Has a bit more of an engineering feel to it. Since I got this from the university physics book, engineers are studying with us when we go into this class, so that makes sense that we would be studying the engineering part of it. Number 6 is modern physics, which mostly consists of relativity, quantum, and atomic cosmology. Those things, the things that I like. Those are the things I find enjoyable. So since I'm an astrophysicist, I tend to speak in larger general terms, macroscopics. So those are some of the things that you'll see here on this channel. I'm more of a big picture person, and I really don't tend to look at the smaller parts in atomic physics or anything unless I need something from them. Like if I need some laws or to drill something home, that's when I'll go to atomic physics or anything else like that. Or like mechanics is a great go-to. Well, that's what we do in astronomy, but it's the building block for everything you need. And quantum is my next go-to. Initially I didn't find quantum that interesting, but when I saw that I needed it, then that's when I turned that attention. So in physics in general, there's so much to think on and ponder, and you never fully have the answer. There's always a million possibilities. So I am so glad, I feel like so blessed that I find this like something that I'm interested in, because it's like I get to learn and I get to study for life. I'm planning on studying this for life, and hopefully I can give it to you guys that is like more like entertaining and you want to see more of it. And almost anything that I do that's like outside of physics, I still like relate it back to physics. Like even the etymology, I'm like, oh, this has so much physics in it, and I'm just like crazy about it. So I feel like, oh wow. Actually astronomy was the first one, as far as the modern physics goes, in the physics was the first one I was interested in. And I started getting more into the actual physics, and I found it was so interesting, and there was like so much to learn. Like I love a good mystery. This is basically like the mystery that keeps giving, and then you just look for the answer. You keep digging and you keep digging, and you can't really stop. Like the answer is so many things. It's all things but nothing. The duality. We can talk about astronomy, my branch, in another video, because it deserves its own video for sure. Thank you all for watching, my little earthlings. Well, you're not my little earthlings, you are your own earthlings. Like and subscribe, share with friends and family, and purchase my book. Purchase the book Quintessence. I feel like I'm making history here. But I see you Earthlings in another video. Bye.